The last part that we're kind of reviewing in Chapter 8, I think we kind of just flew through the organic part. Do you guys remember that? Okay. Remember, when we're naming organic molecules, there are things in the name that tells us what's going on. For instance, in problem number 2, we had this, C2H4. All right? That is the molecular formula for an organic molecule. How do I know it's an organic molecule? Because it's got carbon. If it's carbon, it's organic. All right? What this is saying is that I have 2 carbons and 4 hydrogens. And that I've got to figure out how to put those together so that everybody satisfies the octet rule. Remember what the octet rule is? Nope. Okay. The octet rule is that everybody has a satisfied outside shell or a filled outside shell. Did you guys, where you took chemistry, did you get into SPDF configuration?
Oh, wow.
But I'm good. It's okay. Keep on.
No. Okay. What did you guys do?
Oh, it's been since 2002 for me.
Okay. All right. So, for instance, carbon is in group 4. It can only form 4 bonds, but it needs to have 8 total. So, for instance, if we look at the Lewis dot of carbon, it looks like this. If I look at the SPDF configuration, it's 1s2, 2s2, 2p2.
Yes, you did.
Okay, so you did that?
Mm-hmm.
Okay, good. All right. So what's going to happen is that the carbon and the carbon are going to bond. All right? So this molecule is going to look at least like this. Now, keeping in mind that carbon needs to have 4 bonds and hydrogen can only form 1 bond. So we know the hydrogens aren't bonding together because then they wouldn't be able to bond with anybody else. So I also can't put 3 here and 1 here because then carbon wouldn't be happy. So what's going to happen is a hydrogen's going to go here and here, and another one here and here, and then carbon is going to share another pair of electrons. That's the only way that can happen where everybody's got a satisfied outside shell. Each carbon has 1, 2, 3, 4. These are shared, so they count for both carbons. 1, 2, 3, 4. Each hydrogen only has 1. We've only got 2 carbons and 4 hydrogens. When we name an organic molecule, there are prefixes that we use that tell you how many carbons are in the molecule. So, for instance, if I see a methyl, that is 1 carbon. Ethyl, that's 2 carbons. Propyl is 3. Butyl is 4. Pentyl is 5. I'm just going to start writing them like that. Everybody understand that means 5 carbons. Okay. Hexyl is 6. Heptyl is 7. Octyl is 8. Nonyl is 9. And decyl is 10. So if I were going to name this molecule, I've got 2 carbons, so it's an ethyl something. It's got a double bond in it, so we have endings that tell us what the bonds are. ANE is a single bond. ENE is a double, and YNE is a triple. So this is a double bond. That means it's going to be ethyl E. In some ways, this is easier than naming ionic and covalent bonds. Okay with that? Okay. So, if I had each dash is a hydrogen. All right. How many carbons? 5. So what's my prefix going to be? Pentyl. Cut off the ending, so I have pen. What kind of bonds do I have between my carbons? Single, so it's going to be pentane. All right. If I had hold on. The molecular formula for this would be C5H3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The rough formula for knowing what the molecular formula is if it's a single bond, singly bonded carbon, twice the carbon plus 2 will give you the number of hydrogens. Okay. So, what if, though, I had a double bond here? Now, double bond changes the ending. We still have the same number of carbons. Double bond changes the ending, and it's ENE, pentene. But we have to say where that double bond is. We start from the shortest end, the one closest to the double bond. So I could do from here, it's off the second carbon. So this is 2-pentene. It could theoretically also be called 3-pentene. If we started from this side, they're going to be the same thing. But we need to say where the double bond is. If I had so every carbon's got 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay. If I had that, then it would be 2, 3-pentene. Not so bad. Do you have a question? Just darn happy to be here? All right. And the molecular formula for this would then be C5H3, 4, 5, 6, 7, 8. The other one would have been C5H10. Okay? All right. You've got a listing in the back of the book, on the back cover, of the different functional groups that are involved in organic molecules. A functional group that is something that comes off the chain. So, for instance, if I've got an alcohol is an OH group. Yeah, go figure I start with alcohol. It is an OH group. And it'll be an OH bonded to a carbon within the chain. Typically, you find them on the end. So, if we've got this, we still name it based on the number of carbons. So how many carbons do we have? 3, so it's propyl. So that's going to be prop. What are our bonds like? Are they double, single, or triple? Single. So we're going to put an A right here to indicate that we're singly bonded. The ending for alcohols, each functional group, well, most functional groups have their own specific ending, is NOL. So this is propanol, also known as rubbing alcohol. All right. If I threw in a double bond here, what do you think that would become? Propanol. And it's off the first carbon, so you don't necessarily have to put the 1, but it's always kind of a good thing to clarify where that double bond is. Not so bad. All right. So what would we call that? Pentanol. Because it's 5 carbons, singly bonded, and an alcohol. That would be. Remember, every carbon has to have 4 bonds. So, let's draw the first one. Here's the CH3. Here's a CH, CH,
Yeah.
CH2,
2, 3.
C. All right. Those two, the second and third carbon, don't have enough hydrogens around them, so there has to be a double bond there. Okay, so this carbon, first carbon, 1, 2, 3, 4. Second carbon, 1, 2, 3, 4. Third carbon, 1, 2, 3, 4. Fourth, 4, fifth, 4. 1 double bond. It's on the second carbon. Pent, meaning we've got 5 of them. E, we have a double bond. NOL, we have an alcohol. So that tells us there's an OH at the end.
Wait, how did you know it was on the third, or in between the second and third carbon?
Because those are the 2 carbons that didn't have enough hydrogens around them to make them, to do the 4 bonds. Remember, carbon can do single, double, or triple bond. Carbon and nitrogen are the only ones, in general, that can do triple bonds. Carbon to carbon, nitrogen to nitrogen, or carbon to nitrogen can form double, triple bonds.
I don't know what you mean double, right?
Carbon, oxygen, nitrogen, and sulfur. But then phosphorus and sulfur can also violate the octet rule. Phosphorus, sulfur, and sometimes it's either fluorine or chlorine. Fluorine, I think it is. They can violate the octet rule and form more than just 8, or have more than 8 electrons in the outside shell. They can have 10 and 12. All right. So along those lines, what would that look like? Let's draw the structure. That's the formula. So, first carbon's got one hydrogen off of it. There's a second carbon that has an OH off of it. So now, what's going on then between the two carbons? Triple bond. Why does an oxygen have 4 bonds? What is it about oxygen? What does oxygen look like? The Lewis dot. Let me be more clear. The Lewis dot of oxygen. Do you guys remember what that looks like? It's in group 6. So it's going to have 1, 2, 3, 4, 5, 6. Oxygen's got 2 pairs of electrons that are unshared. Normally, not all the time, but normally those stay paired, unless we get into resonance structures, but those stay paired. So oxygen can only form 2 bonds, but it will have these 2 pairs of electrons. Not that that really comes into play when we're naming them, but it's good when we're looking at the structure. So now, how would I name this? Ethanol. So it's F. No, it's not. Yes, it is. So it's F. Sorry. It's F because it's 2 carbons. It's a triple bond. So there's a Y. And NO because it's an alcohol.
Drinking alcohol.
Not ethanol, no. Ethanol is.
Oh, okay. Yeah, that's right.
Or, I'm sorry, ethanol is. Yeah, that's where I got into trouble at CSU. I told you about the first class that involved organic chemistry that I'd taken. It was 2006. I'd taken organic chemistry in 1982, yes, before most of you were born. And the guy that was teaching it had grown up in Iran, gone to graduate school in Rhode Island. So in English he spoke with a Rhode Island accent and was teaching in a southern school. We couldn't figure out if he was saying ain, een, or ein to save our lives. And it's important. So, we finally got to the point where, write it on the board because we can't understand a thing you're saying. And they go, what? Because he didn't understand what we were saying. So, no, the difference between that and ethanol is simply this. You've got a single bond between your carbons, and so you're going to have
So when you're writing that, you would separate the H and the OH, like you wouldn't put those together?
It's proper either way. You can do this.
You wouldn't say 6 hydrogens?
Yeah, oh yeah. Now the formula would be, and again, we can't have everything done one way. So you could write your formula as C2H6O, or you could write it as CH3CH2OH. Or, that's about the 2 ways to write. So there's multiple correct ways to write the
So you
formula.
would never write like C2H5OH? Like just...
Yeah, you could do that too. C2H5OH. Yep. All of those are right. Just to make things a little more confusing.
But normally they just combine them all.
Yeah, normally they do. This would be the standard way it's written. So for instance, if I gave you, let's see, what do I want to do? So I could give you that, the molecular formula, and say that is an alcohol. And ask you to write the structure. So you know right away, we've got 4 carbons. Since it's an alcohol, we know the O and one of the H's go there. So now I'm down to 6. I've got everything except my hydrogens. I can only have 6 more hydrogens. Where are they going to go? Let's see. 1, 2, 3, 4. Somewhere. There's bonds, either doubles or triples. So if I did this, 5, 6. Or I could put a double bond somewhere. But is that right?
There's one that doesn't have 4.
Exactly. So, where did the rest of them go? Can I do this?
Two double bonds. First one, second.
How does that work? 1, 2, 3, 4,
The
5.
middle one.
You did on my paper.
The middle student.
Do it.
So the third.
Right here. 1, 2, 3, 4. And how many hydrogens? I've got 1, 2, 3, 4, 5, 6. That's all the hydrogens I can do. But that carbon doesn't have enough. So if I do this, 1, 2, 3, 1, 2, 3, 4. Does that work? 1, 2, 3, 4, 5? Nope, 6. So can we do that structure? Did you draw one? What'd you draw?
It don't work. The way I did it just like that, but did the 2 bonds. So I bet the first and second one's the same thing.
One, 2, 3, 4, 5, 6. We're not gonna be able to do it.
So that can't exist.
Yes, that's rain.
Oh, that is right.
Great. So, the car.
Do it? Yeah.
It's soaked.
So that one was the right one?
Yes, I
So-
got my umbrella.
What if we did this?
Get the whole class in here.
He might. Yeah.
Do this and this. So 1, 2, 3. 1, 2, 3, 4, 5, 6. So we can do that.
So you couldn't have C4H7,
Because there's no way to get
get all the.
everybody happy and
So would you give us something like that on the test and we'd have to write,
Yes.
doesn't exist?
no, I would not do that.
Okay.
That would be way too good. All right. So how would we name this?
Beautiful.
So 4 is bute. E. The double bonds. No. And this would be 1, 2
Yeah.
to name the carbons.
So you would tell us it's an alcohol
Mhm.
at the beginning?
I'd have to tell you what the
Otherwise, it
functional
would
would
have to be written the way she was saying, I
Right.
understand that.
Right.
That was on our final exam.
You will.
Yeah, because we did go over this some.
How did you remember that?
Oh, oh,
It's been haunting me.
We did.
I don't know if it was the same one, but
We did go over this some. I mean, we kind of flew over it, but we did go over it in Chem 1.
I remember the one day in class.
yeah.
No, it was a
2
couple
minutes.
days, but
Wee.
it was.
functional groups. Which one do I want to do next?
How many functional groups are there?
In general, we think there's like 7. There's alcohols, aldehydes, ketones, carboxylic acids, esters, and ethers. And I'm leaving one out. Oh, just a general functional group, like you might have a chlorine. Okay. Functional groups can also be represented by just saying R. So R. Oh, I forgot about that one. That one we didn't go into. This, you may see as a functional group. It's called a benzene ring. It's also can also be called an aromatic. In general, you can see it written like this, with a circle in the middle, or you would see it like this. Double bonds alternating.
What do you mean double bonds?
Meaning between each one of these is a carbon. So it's a carbon ring. And what you basically got is a carbon single bonded to a carbon, double bonded to a carbon, single bonded to a carbon, double bonded to a carbon, single bond, and double bond.
Would you have things off of it?
Because you notice you've only got 1, 2, 3 here. So you could have a chlorine off of it, and then over here you could have an alcohol off of it.
So what's the benzene ring? Is that just a way to write it?
That's it. That's it. It's a 6-chain carbon with alternating double bonds. Okay. Something like this.
It's a Ferris wheel.
It is a Ferris wheel. Sorry.
I like that. That was cute.
Fe is iron, which is ferric or ferrous. It's a Ferris wheel. Oh, you get into all sorts of organic chemistry jokes. Like, I hope if I can draw.
So the circle means there's alternating carbon bonds?
Circle in the middle. Now, you also differentiate. If you have functional groups attached to a benzene ring and they're right next to each other, like if they're here and here, that's called ortho. If they're here and here, that's called meta. If they're here and here, that's called para. So that's
Paradise.
paradise. Or if you had two little faces of doctors, that's a paradox. Oh no, that was this. Sorry, not doctors. God. There you go. There's a paradox. Yes, my organic chemistry used to torture us with stuff like that, so what goes around comes around. We also we had 2 Great Danes, and he would love to bring those dogs to class when we're in organic lab. An organic lab can go boom very easily. Matter of fact, I remember the best looking guy in our chemistry class. Best looking guy, just gorgeous. Set up his apparatus, his distillation, and back then we didn't have the electric hot plates and stuff like that. We were using Bunsen burners and alcohol, and if you didn't tighten everything up and put enough stopcock grease on things, then it would leak, and his whole apparatus caught on fire. Boom! Burned his eyebrows off. All right, that's really, I'll get into more functional groups tomorrow. I don't want to overwhelm you guys with everything. So I'll try to get a worksheet together to help you guys out with naming, things like that, and post it on Angel today. And like I said, if I'm late tomorrow, just bear with me, because I'm doing the bouncy balls for the teachers.
For the teachers?
For the teachers.
The last cleared out there.
Not yet.
Okay. I was just making sure. 'Cause I
No,
couldn't
I
find it.
forgot.
No, it's not a big deal. Don't be in a hurry.
I flat out forgot. But as I was